In this video, we're going to get more practice with square roots and simplifying the radicals. So if I look at my first example, we have square root of negative 27, x to the fourth y squared. So what I'm going to do different in this video is I'm only going to break apart the coefficient, and I'm going to leave all variables together. And maybe we can see if we can do a quick simplifying that way. First thing I'm going to notice is I have a negative inside the radical. So I'm going to take that out and make it an I. So I have I, and I have square root of 27, which I'm going to have to simplify. And then I said I'm going to leave all the variables together and do them all at one time. So if we take a look, let's simplify the square root of 27. Well, that's 9 times 3, which 9 is 3 times 3. So I have a pair of 3's, which one can come out, and then 1 3 remains inside. I still have that I. I'm going to bring it down. So I have I times 3 radical 3. And now I'm going to simplify all my variables at one time. Multiplication going on, so I can use the trick of dividing the exponent by 2. So x to the fourth, the square root of it, divide x to the fourth by 2, divide the 4 by 2, and you get x squared. Y squared, so divide 2 by 2, and you get y to the first, which is just y. So put it all together, piece it all back together. On the outside, I have a 3, an x squared, a y, and then an I. So I have 3x squared y, then my I, and all that remains on the inside is a radical 3. And so that is the simplified version of the square root of negative 27 x to the fourth y squared. So let's take a look at number 2. Now this is interesting because I can see in number 2 that I have a parentheses, a binomial that's being raised to the 7th power. So let's see how we can do that. Let's separate that away from the 32. So we have the square root of 32. We're going to have to simplify that. And the square root of x plus 1 to the 7th. Let's do the easy one, which is the square root of 32. I'm going to break it down into 16 times 2. The reason why I'm using 16 is because it's a perfect square. And so you can break a perfect square into a pair of the square roots. So I can take a 4 out, and a 2 remains inside. What about the x plus 1 to the 7th power? Well, this whole parentheses is being raised to the 7th power. That means there's 7 x plus 1, 7 of those parentheses lined up, being multiplied together. Well, how many sets of those parentheses do you have? It's the same trick we learned before. Since this parentheses is being raised to the 7th power, we don't care about what operation's going on inside of it. I'm just trying to identify how many sets of this parentheses do I have when I take the square root. How many pairs of 2? So 7 divided by 2 is 3. So I'm going to have 3 pairs of that parentheses on the outside. And I'm going to have 1 set of the parentheses that remains on the inside. So we're going to piece it all together. On the outside, you have a 4 and that x plus 1 to the 3rd power. On the inside, you have a 2 and the x plus 1. And so that is my final simplified answer. So though in a previous video I said if you have plus signs, minus signs, you got to be careful with simplifying radicals. You can't do it across the plus sign, minus sign. That is true. What's different about this one is that plus sign is contained inside of a parentheses. So I don't care what's in the parentheses because I'm looking for sets of the parentheses itself. And there's 3 sets of this, and I can simplify that way. So it even works like ones in number 3, where we have 20 square root of 16, 3x to the 8th power. That 20 is on the outside. I'm going to have to keep that in play. It's always going to have to be there. We're going to use it at the end. And then break it apart. Square root of 16 times the square root of 3x to the 8th. Well, the square root of 16 is 4, so I have 20 times 4. Same idea. I don't care about what's in the inside. I don't want to raise it to the 8th power. I have 8 of these parentheses being multiplied together. So how many sets of 2 do I have? Well, 8 divided by 2 is 4. So I have 4 sets of that parentheses. So 4 sets of 3x. Now we simplify. 20 times 4 is 80. 3 to the 4th is 81. And then x to the 4th. And then simplify from there. I get 80 times 81 as 6,480 x to the 4th. Same idea. 2 is already on the outside for this, so you're going to have to keep it there. Break it apart. I have square root of 125, and I'm going to put all the variables together. X to the 5th, y to the 6th, z cubed. If you want to break them all apart, go ahead. We're going to have to simplify the radicals. 125 is 5 and 25. 25 breaks into 5 times 5. So I have on the outside my 2. Radical 125 breaks into 5 square root of 5 because I have one more 5 remaining on the inside. And then I break apart x to the 5th, y to the 6th, z cubed inside the square root. Well, 5 divided by 2 is 2, so I can pull out 2 x's, so x squared. And there's going to be 1 remaining inside. 6 divided by 2 is 3, so all of them come out. 3 divided by 2 is 1, with 1 remaining inside. So piece it all together. 2 times 5 is 10. I have an x squared, I have a y cubed, and a z. On the inside, a 5, an x, and a z. So radical 5x z. And so our final answer is 10x squared y cubed z times radical 5x z.